Hi guys, so today we'll be solving this problem called maximum number of K-divisible components. In this problem, there is a undirected tree with n nodes labeled from 0 to n minus 1. You are given the integer n and a 2D integer array edges of length n minus 1, where edges of I is a of I, b of I, indicates that there is an edge between nodes a of I and b of I in the tree. So we are also given a k value where we need to basically create a valid split of the tree by removing a set of edges from the tree such that the divided tree can be divisible, the values of the divided tree can be divisible by k. So yeah, that's what it's written here. A valid split of the tree is obtained by removing any set of edges, possibly empty, from the tree such that the resulting component all have values that are divisible by k, where the value of a connected component is the sum of the value of its nodes. We need to return the maximum number of components in any valid split. So that's the idea. So here in this first example, if we see, we have edges of array, right? So uh, edges, which is 0 2, 1 2, 1 3, 2 4, right? So yeah, that's the edges of the tree, and we need to let's draw this first. Uh, so we have 1, and 1 has a child of 2 and 3, right? We have 2 has a child 4, and 2 is also connected to 0. So this is how the tree looks like. We have the case value as 6, and the value array is 1 8 1 4 and 4. So 0 1 2 3 4, right? So that's the you know the value array. So what we need to do is we need to split this into two halves such that the addition of the values is divisible by k. So value of 1 is, if we see value of 1 in the value array is 8. So I'll just write it here. Value of 3 is 4. Value of 2 is 1. Value of 4 is 4. And value of 0 is 1, right? So we need to divide it in such a way that the components have divisible by k as the sum of the values. So if you see here, 1 and 3, the addition is 12, right? So here the addition is 12. And here if we see, the addition is 6, right? K's value is 6. So 6 is divisible by 12 and 6 is divisible by 6 as well. So we can divide this into two half, right? So if we just remove this, so we can divide it into two components, and that's the answer for this one. Let's try to understand how we can solve this problem. So yeah, once, so yeah, we know that we need to do a traversal, right? So we'll probably do DFS, and in this DFS, how we'll do is uh, we can have a very simple algorithm where we are traversing the tree from the start, and actually we'll yeah, this one is a list, right? So edges list, we need to convert this into a adjacency list. Using the adjacency list, we'll traverse through the tree, and from that tree we'll go through each child node of a node and get its value. And once those values come in, we add ourselves to that value and then check, if the value is divisible by k. If it's divisible by k, we add the component, like we do a component plus plus, and yeah, and we move forward. That's the high level, solution for it. So let's try to understand with an example this one and only. So let's create a adjacency list first. So we have 0. So 0 has 2 as the child, and 2 also has 0 as a child. Then 1 and 2 and 3. So 1 has 2 and 3, and 2 also has 1, and 3 also has 1, right? And then we have 2 has 4. So 2 has 4 as well. So that's the adjacency list, right? So once from there, what we'll do is we'll we'll go through each one by one. So let's start with zero. So zero, does the DFS. So zero calls two, like which is there in the adjacency list. So zero calls two, telling it to give its sum. So we come to two, and two has child as 0, 1, 4, right? So two has child, so two calls four, and two also calls one, right? Two does not call zero because that's the parent node. So we'll add a check that, if it's a parent node, we do not go back so that it does not create a cyclic recursion infinite loop. So yeah, so two calls four saying that, hey, give me the sum. Then four, we don't have anything. So four is actually connected to two only. So it does not have anything else. So two is already a parent node. So it wouldn't go back. So four says that, hey, I don't have anything. I just have myself. So four gives the value as sum as 4. So at 2, we have 4 as the value. And 2 says that, hey, I've got 4. I'll add it to myself and I'll return to 0. So it returns to 0 and returns to 0 as 5. So 4 plus 1, 5, right? So 2 has a value of 1. So we have 5 return to 0. Then 0 is like, okay, I've got 5 and I also have my value as 1. So my sum is 6. So then I check if 6 is divisible by k. If it is divisible by k, then yes. So 6 is divisible by k. So I have like a counter and I do counter plus plus, right? So that will give me the value as 1, right? So that's done. Then 2 calls 1, right? So 2 has also called 1. So 1 is there. So 1 has 8 value. So 1 also has child as 2 and 3. So 2 is already the parent node. So we wouldn't go back. We'll call 3. So we'll call 3 and 4. 3 has a value of 4. 3 does not have anyone else. So just returns 4 back, and 1 adds the 8 to itself. So that becomes 12. So 12 is added here. And 12 plus 1, 2 says that I'll add 1. So it returns 13. And then 13 plus 0, 13 plus 1 here would be 14. So 14 is 14 divisible by k, which is 6. No, it's not. So that wouldn't be added as a component. So that's fine. So yeah, that is done. But at because it's a recursion, so at every stage you will also check if that itself forms a component, right? So at 12, 12 is divisible by k, right? So once we have the value as at 1 as 12, right, the sum. So it says that, hey, I have formed a component with a few nodes. Let me see if I'm divisible by k. So yeah, it sees that it's divisible by k, and that's how it does component 1 plus plus. So that becomes 2. And that's, yeah, basically that's how this tree can be divided into two components, such that its values are divisible by k. Let's get to the coding part to understand it a bit better. First of all, what we'll do here is we'll maintain adjacency list. So adjacency list is equal to, right, of n values. And from there, what we'll do is we'll have create a adjacency list. So in edges, right? So there we'll have adjacency list of node 1 dot append node 2, adjacency list node 2 dot append node 1, right? And once that's done, we'll go forward and we'll do a DFS, right? And there we'll also maintain a counter, as I said. So component count is equal to 0. So this is an array because, yeah, we'll be passing as a reference. So yeah, in the DFS, we'll have the current node and the parent node, and we'll pass the adjacency list. We'll pass the component count, and we'll have edges. Sorry, not edges. We'll pass the values and k and component count, right? And once it's back from there, we'll just say that component count of 0 should be returned. Let's see with the DFS function what we need to do. So we have current node, we have parent node, we have adjacency list, we have values, we have k, and then component count, right? So in this, what we'll do is we'll first of all create a sum, right? So sum is essentially going to give us the the addition of the entire values. So once that's done, we'll iterate through the through the through the adjacency list. So in of current node. So yeah, here we'll check if neighbor node is not equal to parent node, right? Then only we'll call the DFS function. So DFS will be iterated from there. So we'll have neighbor node, and current node then becomes the parent node, and we'll pass the adjacency list, values, k, and component count. Yeah, and this will actually be returning me the sum, right? So I'll add it to the sum. So once that's done, we have sum, right? So sum will be modulo k, so that we always do not exceed that k threshold. So once that's done, we'll have the sum value. So we'll add ourselves to the to the sum then, and then uh, we'll also do a modulo k, and we'll check if sum is equal to 0, which means that is divisible by k, and then we can do the component count of 0 plus 1, right? And then yeah, eventually we return the sum from there. So that would be the idea. uh, we just go through, we'll create an adjacency list, we'll go through DFS, where in DFS we are going through each adjacency list, and we are iterating and just saying that, hey, give me the sum of from all the child nodes, and child nodes then eventually go in a recursive loop and get the sum, and from there we add ourselves to the sum, and then we check, hey, that we are divisible by k or not. If yes, then we add the component counter and return the sum from it. Let's run the code to see if everything is working fine. Yeah, that works. So I hope you guys understood and liked the video. Thank you so much.